I decided to open source a YC company to help developers everywhere. Okay, fine. Honestly, it was mostly out of sheer desperation. Because let's be real, landing a job as a recent grad these days feels harder than escaping Alcatraz. If you're a developer with less than 3 years of experience, you definitely get what I'm saying. And if you don't, I genuinely envy you. Building cool projects and acing coding challenges wasn't cutting it anymore. So I needed to step up my game. So I hopped onto my Discord server and sent out a distress call. Oh, finally, I got something.
You want to talk about Spur, Jared?
Sure. So Spur is building an AI QA agent. So QA engineers who write tests to test your software, and they're just building an AI agent that writes the test for you.
I thought if I can reverse engineer this sorcery, maybe the hiring managers will finally see that I'm serious about my engineering career. I mean, I was as clueless as anyone at the beginning. So I did what any good engineer would do. I researched, or rather, I Googled. I went down a rabbit hole reading every article, blog post, and research paper I could find about Web AI Agent. Here is the simplified version of what I learned. Building a web agent is a lot like teaching a toddler, nudging the AI to think, guide without imposing strict rules. These web agents follow a method often used across the industry. First, the user request is broken down into structured tasks. For instance, if someone says, book the cheapest flight from New York to Miami on April 2, a typical task plan might look like this. Navigate to Google Flights, input the departure city, input the destination, select the travel date, filter the results, choose the cheapest flight option. These agents primarily rely on screenshots captured directly from the browsers as their main input source. Each screenshot is annotated with bounding boxes around interactive elements like buttons, text fields, and drop down menus, and labeled with unique numbers, which are then mapped to textual contexts such as element labels, types, or attributes. Many industry leaders, including Skyvern, OpenAdapt, WebVoyager, and Browser use this technique, commonly known as set mark prompting. Why the numerical labels? They create a direct link between what the agent sees and how it chooses its next action. By pairing the screenshot with the element's textual information and the bounding box number, the agent can accurately navigate without any confusion. With this blended perspective, the agent decides whether to click, type, scroll, or wait, whichever action logically completes the next step in the plan. By cycling through these steps, the agent is able to complete the user task. Now we're going to design the entire architecture of the application. So it's a time for a montage. And for the QA testing app, I needed to do something different. Once the user lists out all the tests in natural language, I generate two crucial things: visual steps and actionable steps. Visual steps will help validate if the task was correctly executed and handled without any errors. Actionable steps define how to actually implement the task within the browser. When it comes to generate browser action, instead of relying on set mark prompting like many traditional agents, I use step prompting. This strategy, combined with more powerful vision language models like Sonnet 3.5 or Qwen 2.5 VL7B, allows me to drastically cut down the text and image tokens by nearly 80% while maintaining the performance that's on par with others. Once the QA testing process is up and running, I got to work with the front end. And for the communication between the web app and the Docker containers, I use the Node API. The main goal of this app is to implement the AI QA testing where the agent. I decided to keep it simple and skip the GitHub integration for now, which would automatically run tests on code pushes. I kept things simple for now. Check out the GitHub for the entire code. The users can add QA tests on any public URLs. Once the user adds the test steps and runs the test, a Docker container is launched in the Kubernetes cluster, runs the test, and sends live browser previews and logs back to the database. Okay, that's enough. Let's see some demo. QA test on Hugging Face. Open the Hugging Face site, search for Qwen models, pick any model from the list, and check if the documentation has a quick start section. Go to Trello, log in with your credentials, and move a card from the to-do list to in progress. You can see that sensitive information isn't exposed during tests. You can safely set your credentials in the config tab so they stay private and never shared with the LLMs. I don't know whether it will help me land a job, but it was a fun project. And for recruiters who's asking me if I got an experience building or fine-tuning models. Oh, I've got an idea.